Alright, in this video we're going to talk about electronegativity, so how can we implement this information, the electronegativity values, for determining ionic or covalent bonds. Alright, so here this table tells us, this periodic table gives us the electronegativity values. The electronegativity of fluorine is 4, the quantitative value, and the francium is 0.7. And when I look at sodium is 0.9, when I look at the carbon is 2.5. Right? That number tells us how much they love electron, how much they are how electronegative they are. Obviously, the highest number is 4, the lowest number is 0.7 here, so the fluorine is being the most electronegative element, and here we got chlorine 3, and the least one is francium 0.7. So that number tells us how much they love electron. For example, chlorine loves 3 much, and then sodium loves only 0.9 much, right? This is 3.0. Is this 0.9? Well, obviously, chlorine wants to get an electron a lot, but not sodium, right? Sodium wants to lose it pretty much, right? 0.9 is a pretty low number. So chlorine has the valence electron like this, and then sodium has just 1. So sodium wants to lose 1, and chlorine wants to gain 1, right? Because chlorine wants to be like noble gas. We know that already. And then they'll do it and we'll get the table salts, right? Sodium chloride. Okay. So electronegativity is nothing but just the quantification of how much they love electron. So let's do here another one. For example, we have hydrogen here, and then we have hydrogen here. They both want to gain 1, right? However, they cannot find it, so what they'll do, they'll share. So we have hydrogen here, and then they will share electrons, and then we got H2. This is going to be a covalent bond. This is ionic. So ionic bonds are when they transfer because one's love more than the other, and then the one are sharing, which they're both the same way, and then they got covalent, they form covalent bond. So here I'm going to do something else. I'm going to do HCl this time. So hydrogen here is 1 electron, and chlorine has 7 electrons, 7 valence. So now what? So are we going to transfer electron, or they're going to do sharing? Well, that depends on the difference of electronegativity values. So here for hydrogen, the value for hydrogen is 2.1 and chlorine is 3. So hydrogen is 2.1 and chlorine is 3. Hydrogen still likes it. He doesn't want to. Hydrogen still likes electrons, right? But hydrogen doesn't want to lose it. So now what? Now what's going to happen? Well, they will share. So 2.1 versus 3, they both like electrons. So they will share, but the share is not going to be symmetric, or it's not going to be fair share. So chlorine is more electronegative. So when they want to share, hydrogen's electron will be towards to the chlorine more than hydrogen, right? It's going to be like towards to the chlorine here. So you have HCl. This is a covalent bond, but we call it a polar covalent because it's polarized. So when you look at this molecule, you have an electron cloud like this. So you have a positive side of the molecule, and then you have a negative side of the molecule because electrons are towards to the chlorine. So you have a polar molecule, okay? So polar covalent bond is covalent bond with greater electron density around the one of the atoms. So here's the cutout, okay? This is very important. So if the difference is 0, we will call it covalent. For example, hydrogen and hydrogen, right? It becomes H2. They want to share equally. The value for hydrogen is 2.1. Another hydrogen is 2.1. Difference is 0. So if you are getting more than 2, like sodium and chloride, sodium is 0.9 and chlorine is 3. Difference is more than 2. So it's going to be ionic. All right? So the numbers in between is going to be polar covalent. That's pretty much it. Okay, so if the electronegativity values are more than 2, they want to transfer electron, and then you'll get ionic compound. But if the difference is 0, which basically means the same element, it's going to be just pure covalent. But if you have in between is not 2, the difference is not 2, but not 0 as well, then it's going to be a polar covalent. Electrons are going to be shared, but not equally. All right. For example, here, when I look at the table from the electronegativity values, which will be provided in the exam, hydrogen is 2.1 and chlorine is 3. The difference is 0.9, right? Difference is 0.9. So let me see here. So hydrogen is 2.1, chlorine is 3.0. So 3.0 minus 2.1 is 0.9, which is less than 2 but not 0. So this is going to be a polar covalent. When I look at the potassium and fluorine, fluorine is 4, and potassium, let's see potassium here. Potassium is 0.8. So 4.0 minus 0.8 is 4.0 minus 0.8 is going to be 3.2. That's more than 2, right? And that's more than 2. So it's going to be an ionic. Here is asking carbon-carbon bond in this ethane. Well, you have the same element. The value is the carbon is 2.5 and this is 2.5. Difference will be 0. All right. So it's asking here which of the elements listed below has the greatest electronegativity. You're going to look at the table and you can tell that number, right? That's an easy question. All right, so I'm going to stop here. And then from now on, I'm going to share some other videos. They're more, I think, easier to watch because they are putting a lot of graphing, like images. So it's going to be easy to follow. I'm going to set up all those videos so you can watch to learn the concept, the leftover concept, okay? All right, have a wonderful day.